Okay, I'm gonna teach some stoichiometry problems in chemistry because these type of problems are very common, especially in grade 11 and 12. And it's basically like the foundation of most of the chemistry you will be doing. Okay, so let's look at this problem. Sodium carbonate reacts with nitric acid according to the following equation. Na2CO3 solid plus 2HNO3 reacts to give 2NaNO3 plus CO2 plus H2O. So we can first start off by writing the entire equation again. So just write this out real quick. Okay, now the question's asking us to find the moles of Na2CO3 that are required to produce 100 grams of NaNO3. So we're given the 100 grams of NaNO3. So we can make a sort of chart thing where I have the mass, and then the molar mass, and then the moles. And for the mass of NaNO3, I know it's 100 grams, so I can write that down. Now, next, what you're going to do is, you can't use this information yet, right? So, but you know you can find the molar mass of NaNO3. So what you would do is, on the side, you can just calculate it. Na has 22.99 grams per mole, right? N has nitrogen, 14.01 grams per mole. And then oxygen has 16 grams per mole. Now when you're calculating, you want to add 22.99 plus 14.01 plus 3 times 16.00 because you have 3 oxygens and only one Na and one N. And I'll write it like this. So you would get if you use a calculator, you get a mass, a molar mass of about 85 grams per mole, right? And we'll just do that. Okay. Now that you have this value, you can plug it into here, right? Now you can find the moles, right? By using the equation N equals to M divided by M, where the N, this is the moles, this is the mass, and this is the molar mass. Keep in mind that the molar mass has a uppercase M and the mass has a lowercase m. So now using my calculator, if I divide 100 by 85, right? Because N equals to 100 divided by 85. You get about 1.176 moles. Now, with this, you can plug it back into this chart thing. So now I have 1.176 moles of NaNO3. Now, we have all this information and we want Na2CO3. We don't have to worry about these compounds, because they're not useful to us and they don't affect anything because we're only searching for the moles for Na2CO3. So to do this, we look at the ratio of these two compounds or molecules. And you can see that the ratio is 1 to 2, right? You have 1 here and then 2 here. So what we do is we take 1.176 moles and we divide it by 2. And when you divide it by 2, you get 0.588 moles. So there you have the moles for Na2CO3. So you have 0.588 moles. That's it for this problem. Okay, let's try another problem. So we're given this equation and it says calculate the mass of silver bromide produced from 22.5 grams of silver nitrate in the following reaction. So let's write down this equation again. So 2 AgNO3 aqueous plus MgBr2 aqueous 2,2Ag solid MgNO3 aqueous. Okay, so now that we have the equation down, we can do the same thing that we did earlier where we have the mass, the molar mass, and the moles. So we're told that the silver nitrate has 22.5 grams, right? And we know that the silver nitrate is the AgNO3. So we put 22.5 grams here. And we can calculate the molar mass, right, from AgNO3 because we know that Ag is 107.87, and we know that N equals to 14.01 grams per mole, and we know that O equals to 16.00 grams per mole. Now, and then we do the same thing where we add up 107.87 plus 14.01 plus 16 times 3. And if we do that on a calculator, we get 14.01 plus 3 times 16. We get about 169.88 grams per mole. So that's the molar mass of AgNO3. Now, we can use this value. We can substitute it into here. And again, we can use that formula where it was N equals to M divided by M. And we do equals to 22.5 divided by 169.88. 22.5 divided by 169.88, and you get about 0.132 moles. Okay, so it's asking calculate the mass of silver bromide. So silver bromide is this one right here. And we look at the ratio, right? And you can see that the ratio is 2 to 2. So we don't need to change anything, and we just move the moles to here. So you have 0.132 moles as well for the silver bromide. And keep in mind also these equations are already balanced. And if you're not given a balanced equation, make sure you check to balance first, because then your stoichiometry, it's going to get all messed up if you don't. Yep. Okay, so now 0.132 moles, we want to multiply it by the molar mass of silver bromide, and the silver bromide's molar mass is, we know Ag already is 107.87, and we can add it to Br, which is, if you look on your periodic table, 79.904, which equals to about 187.774 grams per mole. Now we can use this value. We can take it and we can put it right here. Now using this equation, right, down here, we can rewrite it so it can become N time. So it'd be mass equals to moles times molar mass. So you do 187.774 times 0.132. And you get, times 0.132, you get about 24.779 grams. And we can take that value and we can put it here. So that's our answer. So the mass of silver bromide produced from 22 grams of silver nitrate in this reaction is equal to 24.79 grams. And that's it for this problem.